Okay, so what we're going to talk about today is something that we did in the earlier sections, which is finding exact values of trig functions when we're given angles. Except now it's going to be, we're going to go beyond acute angles. So if you think about it, we know how to find, for example, the six trig functions of 45 degrees or 30 degrees or 60 degrees. Now, we'll also work backwards where we'll be forced to find the angles with given information. But the goal here right now is going to be to find the exact values of trig functions of any angle. Okay. Now, one comment I'll make is the good news is, as mentioned earlier, as far as we're not using a calculator, these 30, 60, 90, and 45, 45, 90 triangles will still be involved. So let's start off by talking about an important idea we're going to need to know to be able to complete this, which is known as the reference angle. Okay, so this is an angle that's identified whenever we are working with angles in standard position. So every angle has a reference angle. So let me first give you the definition of what a reference angle is, and then we'll draw some visuals and you'll see how they work, and we'll start finding some reference angles as well. So a reference angle of some angle theta. So what I'm basically telling you is, look, first we have to be given an angle, and then this angle itself is going to have a reference angle. In standard position, is the acute angle formed by, so before I continue writing, let me kind of focus on an important word here. So you notice how I underlined it. My reference angle has to be an acute angle. If it's not an acute angle, then it's not a reference angle. So remember, all reference angles are acute. Now, the original angle that we're given, that could be anything. It doesn't have to be acute. But the reference angle, when you're identifying it, it's going to be acute. So that's formed by starting from the terminal side of theta. So we're going to start from the terminal side of theta. So wherever theta puts us when we draw it in standard position, we'll start from the terminal side of theta, going to the x-axis. Okay, so once again, just keep in mind that whenever we're drawing reference angles, we always go to the x-axis. Okay, always. So let's kind of visually describe what's going on here. So if I have an angle theta, let's pretend my theta puts me in quadrant 2, for instance. So I draw my theta in standard position. Now to identify my reference angle, see, I start from the terminal side of theta. Now there's two ways I can go to the x-axis, right? Because this is the x-axis. It's either this way, which I don't want to go that way. How come? Because that's not an acute angle, which means I need to go this way. So this, which we can call it theta sub r, which, what are we saying? This is the reference angle of theta. So notice how I started from the terminal side of theta and I went to the x-axis. And remember, you could argue that, hey, I could go to the x-axis two ways. One is this way, the other one is this way. Well, obviously I want to go the way that makes it acute. That's why I identified it, okay? So then what if we have, so another visual would be something like this. If I draw it and then my angle theta is negative and it takes me all the way around, puts me there, so that's theta. So what's my reference angle? My reference angle is right there. So once again, I started from the terminal side and went to the x-axis. So that's theta sub r. Lastly, there's one other example I want to show you, which you might be wondering, well, why don't we talk about reference angles earlier? Why do we talk about it now? Well, imagine if theta puts us in quadrant 1. what do you notice here? What would my reference angle be? Start from the terminal side and go to the x-axis. And if you think about it, the only way I could go to the x-axis while keeping it acute is the same thing as theta. So it's the same thing as theta sub r. So this is why in section 1 we didn't talk about reference angles, because all the angles we dealt with were in quadrant 1, and as long as all the angles we dealt with theta were acute angles, and as long as your angle is acute, then your reference angle is going to be the same thing, right? So just keep that in mind. Reference angles really become important when we have angles that aren't acute. So let's do our first example where we'll see how we find reference angles. So find the reference angles of, and let me write these down, 71 degrees, B theta equals negative 170 degrees, theta equals 315 degrees, theta equals 432 degrees, and E theta equals to 1200 degrees. So maybe you'd want to watch me do the first one, and then you might want to pause the video and watch, try to do B, C, D, and E on your own, and then press play again. I'd recommend that just so you get some practice on your own. So as mentioned before, I like to do these visually, so I'm going to work on all of these and I'm going to draw them out visually. You don't have to do this visually. You can try to do algebra in your head or add and subtract if you'd like, but I personally, for me, if I could draw things out, it's going to be a lot cleaner for me to see. So 71 degrees puts me in quadrant 1, and what do I notice? Since this is an acute angle, my reference angle would still be 71 degrees, because remember, our reference angle starts from the terminal side, goes to the x-axis. Now let's look at negative 170 degrees. That just, the negative means rotate clockwise, so that's negative 90. Negative 170 is going to come up just short of 180, which puts me there. So that's negative 170 degrees. So my reference angle is going to be what? It's going to be the distance from my terminal side to the x-axis. And one other thing I wanted to point out is reference angles are always positive. So your reference angle will never be a negative number. Okay, so in this case, theta sub r, so from 170 to 180 right here, that has to be 10 degrees, right? Because remember, we know a straight angle is 180. So if that's 170, that would have to be 10. So that's 10 degrees. Okay, now let's look at 315 degrees. 315 would say what? That's 90, 180, 270. I need to go 45 more, which puts me there. So that's 315 degrees. Now I need to find this angle as my reference angle, which, what do I know? A complete circle is 360, but if I take away 315 of it, because that's 315, I'll be left with this much. So if the whole thing is 360 minus 315, that leaves me a reference angle of 45 degrees, which then theta sub r is 45 degrees. So it's important to identify your reference angle, and then notice how I'm using the idea of what? Half a circle is 180 degrees, a full circle is 360 degrees, and I'm using that to kind of help me find the reference angle. Okay, so 432 degrees. That's greater than 360, right? So I know that I've gone 360. That's 360. Now I need to go how much more to get to 432? I need to go 72 more. And I think that was the answer pretty much. We figured out if that's 432, that's my reference angle. And notice how when I got to 360, I said I need to go 72 more to get to 432. So then my reference angle is 72 degrees. So theta sub r is 72 degrees. Okay? Now the last one is 1200 degrees. We're going to be moving in circles quite a bit. So that's 360, 720, 1080. If I go 90 more, that puts me where 1170. And then I need to go 30 more, which puts me there. So that's 1200. Okay, so notice how I said this was 30 more. So this is my reference angle. If this was 30 more, then this is 60. So my reference angle here would be 60 degrees. Okay. Now, one other thing you could have done for the 1200, you could have kept subtracting 360, which would make this angle smaller. And then once this became between 0 and 360, that would have also gotten the job done as well. So basically what I'm saying is, because anytime we subtract 360, we end up in the same place, right? So the reference angle shouldn't change. So if I were to say, hey, look, I'm going to keep subtracting 360 from 1200, which if you keep doing that, see, if I subtract 360 once, it'll be 840. And then if I subtract another 360, I get 480. And if I subtract another 360, I get 120. So if you subtract 360 3 times, this gives you 120. Which then you could draw 120. Let me do it off to the side. You could graph 120 degrees, 90, 120. Which notice how this puts you in the same place as that one did, right? Because every time you subtract 360 or add 360, you end up in the same place. So you notice, hey, if that's 120, then this would have to be 60 degrees, which notice how you got the same thing out of it. So however you want to do this is it's up to you. Okay, so now, now let's talk about kind of the steps of how we're going to find our exact value of trig functions. So if you notice this, I gave you these steps earlier on in our notes, except now we're going to make an addition to it, because the steps when I gave you earlier on in our notes only accounted for acute angles. So when we are given any angle and are asked to find the exact value of any trigonometric function, we will follow these steps. Okay. So like I mentioned earlier, these steps that I give you shouldn't be any different than what we saw earlier on in this chapter, where I gave you the steps, except it's slightly updated. Okay, so that's how I would mention this. But I would say this updated version is the better version, because then everything is actually, it'll work for any angle, whether it's acute or obtuse. Okay, so the first thing we're going to do is we're going to say draw the angle in standard position. Okay, so you'll notice that none of this is new, and now the second step is the updated. So if you look at your older notes, you'll see the second step is missing. What you do is you draw the angle in standard position, then you identify the reference angle. And I'll make a comment about this. When you identify your reference angle, and if I don't expect you to use a calculator, which on the exam I'm probably going to tell you, hey, no calculators allowed for these types of problems, your reference angle better be of 30, 60, or 30 degrees, 60 degrees, or 45 degrees, which means it's going to be one of those nice triangles we're working with. Or you might get a quadrantal angle, which then we won't even need reference angles, right? Quadrantal angle, we just pick a point and identify x, y, r right away. So then we would create a right triangle by choosing a point on the terminal side to the x-axis. So if you remember, we were creating right triangles, so same thing as before. And then we pick any side of the triangle and assign it any appropriate value you would like. So once again, what I mean by appropriate value is, remember, x and y could be negative depending on which quadrant we land in. So technically speaking, I know that I write the length of the side as a negative number. I'm not saying the length is negative, it's just the direction we're moving in. And you'll see that when I talk about it or when we do an example. Okay, so then once we do that, and remember, if my reference angle is not a 30, 60, 30 degrees, 60 degrees, or 45 degrees, then I'm going to have to use my calculator anyway. So we're assuming we're not using our calculator, so then we're going to say use the ideas of 30, 60, 90 and 45, 45, 90 triangles to find the other two missing sides. And when we do that, this will give us, which gives us x, y, and r. Okay, so then once we do that, then comes the easy part. Then we can say, hey, then you can give the exact values of the trig functions. Okay, so in all honesty, the hardest part is finding your x, y's, and r's. So if you follow through these steps, and these steps should look very familiar to you, like I said, you've seen them before. So let's look at some examples where we'll put this to use. And then we'll work backwards, okay? But let's not worry about working backwards just yet. So for example 2, we're going to say evaluate sine theta, cosine theta, and tangent theta of, given A, theta is 315 degrees, B, theta is negative 120 degrees, C, theta is negative 210 degrees. Okay, so let's do 3 examples. And then once again, if you want to pause after I do the first one with you, then try to do the next 2 on your own, you're more than welcome to do that. And in fact, I would recommend it. So if you remember, what's the first thing we said? We draw this angle in standard position. So 350 degrees, that's what, 90, 180, 270, 315 puts me there. And then the next thing I want to do is identify my reference angle, which once again, this is 360. If I take away 315, that'll give me that amount, which is 45 degrees. So as mentioned, and notice how I got a 45 degree reference angle. Then what do? Create our right triangle, which gives us a 45, 45, 90 triangle. Then you pick any side, call it any value you want. So look, if this is, I'm going to pick this side, call it 1. And what do I know? Since this is a 45, 45, 90 triangle, this side is also 1. But now let's be careful, because remember I said we have to assign appropriate values. So since I'm going downwards, I'm in the 4th quadrant, so my y values in the 4th quadrant are -1. So I'm not saying the length of this is -1, I'm just saying since I'm moving down, I'm going to put -1 for y. So notice how the x value and the y value are the same. The numbers are the same, except this one, since I'm moving to the right, is positive. This one, since I'm moving down, is negative. And then if these two sides are 1, then the hypotenuse is rad 2. And remember, r is always positive. That will be never negative. The only things that could be negative are x's and y's. So in quadrant 2, x would be negative, y would be positive. In quadrant 3, both x and y would be negative. Quadrant 4, x is positive, y is negative. So notice now we have x, y, and r. So then I could answer this question. Sine of theta, but now we know what theta is. Remember, when you know the angle, you write it out. So sine of 315 degrees is y over r, so it's -1 over rad 2. Now if you rationalize it, you get negative rad 2 over 2. Cosine of 315 degrees is x over r, so it's 1 over rad 2. And if you rationalize that, you multiply top and bottom by rad 2, you get rad 2 over 2. And then lastly, tangent of 315 degrees is y over x, so it's negative 1 over 1, which is negative 1. Okay, so if you'd like, I would recommend that you pause the video and try these two on your own and then press play. But moving on to negative 120 degrees, if I draw that in standard position, the negative just means rotate clockwise, so negative 120 puts me there. Okay, now once again I identify my reference angle, so if that's 120, then this would have to be 60, because remember these two give me a straight angle, so that's and it has to add up to 180. So once again, notice how I have a 60-degree reference angle, which that's suggesting I don't need a calculator to figure this out. Remember, so if this was like a 58, for example, which that we don't know how to work with, then we would need to use a calculator. But as long as my reference angle is 30, 60, or 45 degrees, we're good. So I make my right triangle. So notice now this becomes a 30, 60, 90 triangle. So now we pick a side and call it whatever we want. So remember, for 30, 60, 90, if it's up to us, we prefer the shorter leg, which is opposite to 30 degrees. So I'm going to call this 1. But since I'm moving to the left, it should be negative 1, right? Because this is in quadrant 3, so I have to move left. And then we know that if we have the shorter leg, we can get to the longer leg by grabbing the 1, multiplying it by rad 3. So notice how I'm not showing any concern for the sign until I find the value. Then I'm saying, hey, this is rad 3, but since I'm moving down, it should be negative, right? So don't worry about the sign until after you find a number and then decide, hey, is it positive or negative? And in the hypotenuse, what do? We grab the shorter leg and we double it. So if the shorter leg is 1, if I double this, I get 2. Okay? So x is negative 1, y is rad 3, r is 2. So now I could answer this question. So sine of negative 120 degrees is y over r. So negative rad 3 over 2. And by the way, if you're wondering why I put parentheses around this and over here I didn't put parentheses, it doesn't matter. They mean the same thing, except since this had a negative, I'm just putting it so it looks cleaner. But whether there's parentheses or not, so for these guys, if I put parentheses or not, it's still the same thing. It's fine. Okay. And then we have cosine of negative 120 degrees is x over r, so it's negative 1 over 2. And tangent of negative 120 degrees is y over x, so it's negative rad 3 over negative 1, y over x, which is rad 3. Okay, now going on to the last one, which is negative 210 degrees. That's negative 180, negative 210, puts us here. So my reference angle is here. So if you think about it, to get from here to here, see, this was 180. How much more do I need to get to 210? It's 30, which is what this reference angle is. Maybe I should make this a little bigger. Okay, so now notice how I kind of got into the problem, but that's fine. This becomes a 30, 60, 90 triangle. So once again, we pick a side, call it whatever we want. So I'm going to pick the shorter leg again, which is opposite 30. I'm going to call that 1. And then to get from the shorter leg to the longer leg, I have to multiply by rad 3. So 1 times rad 3 is rad 3, except since I'm moving to the, see, this one, since I'm moving up, it's going to be positive 1. This one, since I'm moving to the left, it's going to be negative rad 3. And then how do I find the hypotenuse? Well, if the shorter leg is 1, you double it, which the hypotenuse is 2. So once again, x is negative rad 3, y is 1, r is 2. So we can now answer this question. Sine of negative 210 degrees is y over r, which is 1/2. Cosine of negative 210 degrees is x over r, which is negative rad 3 over 2. And lastly, tangent of negative 210 degrees is y over x, which is 1 over negative rad 3. And if you rationalize this, you get negative rad 3 over 3, right? Because all I did is multiply top and bottom by rad 3. That's what I did. Okay? And those are our answers. So let's talk about the last idea here. So now what we're going to do is, which technically speaking, it's kind of like we're working backwards. we will now work backwards. Okay, so that is what we're saying. If you look at the earlier example we did, what happened? We were given the angle and we were asked to find the exact values. Now we're going to work backwards. So we will be given the exact values of a trig function and we'll be asked to find all angles that produce that exact value. Okay, so sometimes we might have infinitely many possible angles that work. Sometimes we might have one or two. It all depends on if we have any restrictions or not. Okay, but here are the steps to follow. And what you're going to notice, it's kind of going to be what we saw earlier, but backwards, right? Because if you think about it, when we were given the angles and we're finding the exact values, what's the last thing we found before we can give the answers? We found x, y, and r. But in this step, what's the first thing we're going to do? We're going to identify x, y, and r, which hopefully makes sense to you because, like I said, we're working backwards. So the last thing we did when we were given angles to find the exact values was find x, y, and r. But now it's kind of like we've been given the information about the exact values, which we should be able to find x, y, and r first. So then, once we do that, then we're going to draw a picture. So we're going to say draw the angle or angles, we might have more than one, in standard position and create your right triangles. Using x, y, and r. So basically the x, y, and r you got in one, you're going to use x, y, and r to create your angles, okay? So what I want to point out to you is usually there are two angles exist between 0 degrees and 360 degrees. So if there are any restrictions between 0 and 360, there's usually two. And if there are no restrictions and infinitely many with no restriction, if there are no restrictions. Okay, so if you have a restriction that's saying, hey, we want all angles between 0 and 360, usually there's two. Expect two. But if there are no restrictions, you're always going to have infinitely many. And the example we'll do, we won't put any restrictions, so you'd see how we can write out there's infinitely many. Okay, so once you draw your triangles, then we basically label x, y, and r. And maybe this shouldn't be its own step. I think you pretty much do that in step 2 also, but we'll just write it out. It's important that you label it. Now, why are we labeling x, y, and r? Because then we want to try to identify the reference angle for each angle theta. And once I do the example, hopefully this will make a lot more sense. But then once we see x, y, and r, hopefully you'll see, if I can't use a calculator, you'll see that your x, y, and r should match those of a 30, 60, 90 or a 45, 45, 90 triangle, which means your reference angle should be either 30 degrees, 60 degrees, or 45 degrees. And then once you identify your reference angle, then you can tell me what the angle is, what the original angle is in standard position. So then we would state the angle in each case. So notice how over here we're finding the angle last, where in the other one we're drawing the angle first, because obviously we're working backwards. So one other comment I want to make is when you state your angle, we need to make sure that, so if there are no restrictions, then always add 360 times k, where k is any integer, to list all solutions. Now, why am I adding the 360? It's because what we're saying is if there are no restrictions, then if you keep adding 360, you'll end up in the same place, right? So if I have restrictions, then obviously I'm not going to need that. If I don't have restrictions, then we're going to put the plus 360k to make sure we capture all the angles that satisfy this condition. Okay, so these steps, I think it's important for you to reference once in a while and make sure that you're kind of going through these steps. So you'll see that the next example I do, I will pretty much use these steps to go through it. Okay, so let's now move on to our last example. So find all angles satisfying the relationship given. So A, sine of theta is 1/2, and B, tangent of theta is -1.2. Okay, now one of these two we're going to need to use a calculator, and I think you pretty much be able to tell, because see, for part A, if we look at this, we know what's the first thing we want to do is we want to identify our x, y, and r, right? Remember that was the first thing. So notice how sine of theta is what? Y over r. So y is 1. Oops, sorry. Y is 1. R is 2. Now we need to find x. How do I find x? If you remember, these are the sides of a right triangle. So we would have to use the Pythagorean theorem. So we know that x squared plus y squared equals to r squared, which would mean x squared plus 1 squared equals to 2 squared, which then becomes x squared plus 1 equals to 4, and that means x squared equals to 3, subtracted 1, which means x equals to plus or minus rad 3. Okay, now look, why am I getting plus or minus? Because when we take the square root, we have to take the plus or minus. So what's happening here is we're saying now, if I come back up here, x is plus or minus rad 3. So what is this suggesting? That there's two angles. And by the way, since we have no restrictions, we know that we're going to have infinitely many solutions as well, but let's not worry about that. There's two cases here. Case 1 is when x is positive rad 3. Case 2 is when x is negative rad 3. So if you remember, I said use x, y, and r to draw your angle. So how are we going to do that? Well, let's break this up into cases. So case 1, we're going to say x is rad 3, y is 1, r is 2. And case 2 is what? X is negative rad 3, y is 1, r is 2. Okay, so let's go one case at a time. So for case 1, let's draw this out. My x value is rad 3. My y value is 1. So my angle, its terminal side, goes through what point? Rad 3 comma 1. Right? So this point was just found literally by plotting the point rad 3 comma 1. So my angle is that. But remember, my goal is to find what? My goal is to find the angle that puts me here. So my goal is to find that angle. Okay? So if I make my right triangle, what do you notice? This is rad 3, 1, and my r is 2. So hopefully these numbers look familiar to you, because look, this is 1, this is 2, this is rad 3. So remember, what kind of a triangle is it? When you go from the shorter leg to the hypotenuse, you double it. And then when you go from the shorter leg to the longer leg, you multiply by rad 3. It's a 30, 60, 90 triangle. And this angle that I care for right there, which is also my reference angle, by the way, my reference angle is what? Opposite the shortest, which is 30 degrees. And in this case, my reference angle ends up being the actual angle, right? Because it's in quadrant 1. So if my reference angle is in quadrant 1, when you have an acute angle, your reference angle and the actual angle are the same. So the angle I want is this guy, because I'm starting from my initial side, going to the terminal side, which is my 30 degrees. So we're going to say in case 1, my angle is what? Theta equals to 30 degrees. Now, since we have no restrictions, we're going to put plus 360 times k, where k is any integer. Now, the reason why we do this is because if you said, hey, the answer is 30 degrees, I'd say, no, wait a minute. I was thinking of 390 degrees, which technically speaking, 30 degrees and 390 degrees are not the same angle as far as the value is concerned, but they end up in the same place. So to cover our bases, we put the plus 360k to make sure that we don't run into any problems there. Okay, now for case 2, what is it that we have? We do the same thing. So except now my terminal side of my angle that I'm looking at ends up where? X is negative rad 3, which means that I'm moving to the left, and y is 1. So to locate the point on the terminal side, it'll be at negative rad 3 comma 1, which then we draw that. And then you make your right triangle. So same steps, right? We draw the angle out, we make our right triangle. So this length is what? Negative rad 3, 1, 2, which notice once again it's a 30, 60, 90 triangle because of the 1, 2, rad 3. And then my reference angle is what? Opposite, actually the shortest side, so my reference angle is 30 degrees. But look, the angle I want is no longer 30 degrees. What is the angle I want? The actual angle that creates this starts where? From the x-axis and goes this way. But notice how, since I know what my reference angle is, which is 30 degrees, this angle would be what? 150. How did I get 150? Because look, 150 plus 30 gives me the straight angle, which is 180. So if this is 30, this has to be 150. So the angle that, so notice now going back here, the angle that starts from the initial side or the x-axis and goes to the terminal side is the same as the reference angle. But over here, the angle that starts from the initial side and goes to the terminal side is not the same as the reference angle. So I use the reference angle to help me find that angle. So this becomes what? Theta is 150 degrees. And once again, since we have no restrictions, plus 360 times k. And then we have to also say where k is any integer. Okay, like that. Okay, so now for this one, when you see a especially when you see a decimal like negative 1.2, right? This one we can't use, we need to use a calculator. We can't do this without a calculator. So the problem here is usually the ones that have nice numbers, like the ones we're used to seeing, like 1/2 or rad 3 over 2 or rad 2 over 2 or anything that has rad 3s, rad 2s and 1s and 2s, we have a good idea that we don't need to use a calculator. Now negative 1.2, if you think about it, that's negative 5 over 4 if I'm going to write that as a fraction. Now if you think about it, the 30, 60, 90, 45, 45, 90 triangles, none of them created sides that had like 5 and 4 in them. So that right there is an indicator that we have to use our calculator. So what we're going to do is we're going to use our calculator to find the first angle, and then we have to use our ideas as to when our angle or when tangent is negative. In fact, remember how I said we should expect to find two angles between 0 and 360? So let's kind of go off to the side. And before we use our calculator, let's use our ideas here to help us find where the two angles should land. And notice how tangent of theta is what kind of number? Is a negative number. Now if you remember when we talked about when trig functions were positive and negative, for tangent, where was tangent negative? Remember, when y or x, one of the two is negative, that's when tangent will be negative, because by definition tangent is y over x, which that would be quadrant 2, because over here x is negative, y is positive, and the other one would be quadrant 4. So the two angles that I want, preliminary, before I add the plus 360k, because remember we have no restrictions, is basically going to be in quadrant 2 and quadrant 4. Now you might be wondering, hey, what if I did have restrictions between 0 and 360? Coming back to part A, if I did have restrictions between 0 and 360, then my answers would be what? 30 degrees and 150 degrees, because then once I go beyond that, then I'll go out of bounds, okay? But since we had no restrictions, I'm adding the plus 360k. So how am I going to use my calculator to find the first angle? Well, if you remember, when we did our application problems, to get rid of the tangent to find just theta, I'm going to tangent inverse both sides, which then is going to give me what? Theta is tangent inverse of negative 1.2. So our calculator, unfortunately, is only going to give us one of the two angles, and we got to figure out the next one. So if I use my calculator and I find tangent inverse of negative 1.2, I will get negative 50.19. So we could say negative 50.19 degrees. And you could, since we have no restrictions, you can leave your angle as is. If we did have a restriction, then you would just add 360. If let's say I want to be between 0 and 360, you just add 360 to make this positive, right? But here's what we'll do. We'll say, look, our first angle is what? Negative 50.19, which means go this way. Negative 50.19. Okay, so when you look at this, you notice, wait a minute, my first angle that's been given is what? Negative 50.19 degrees plus 360k. And then k is, make sure to say that this is an integer. Okay, now, how do I find my second angle? Well, look at this. We got our first angle, which was in quadrant 4, so we got that one. We know our second angle has to be in which quadrant? It has to be in quadrant 2, okay? But how do I find my second angle? Now, here's where I'm going to go back to the first problem, because I feel like we're going to get so much important information out of this. And this isn't by coincidence. If you look at your first angle and your second angle, what do you notice about the reference angles? 30 degrees, 30 degrees. And that's not a coincidence, which means whenever we're working with these and we get two or more angles for one specific problem, my reference angle will not change. So the nice thing about that is, what do I know about the second angle? Whatever the second angle is, its reference angle has to be the same as the reference angle of that guy. So what is the reference angle of this guy? Well, since this is acute but it's negative, remember reference angles are always positive, the reference angle for this guy won't be negative 50.19, but it'll be 50.19, which means this reference angle should be what? 50.19. So the reference angles will not change. That's not a coincidence. It'll be the same. So let me actually write that bigger. That's 50.19. So the second angle I want, which is this guy, would be what? 180 minus 50.19. And if you take 180 minus 50.19, and the reason why it's 180, because look, the whole thing is 180. Now to get this much, to stop here, I have to take away the 50.19. That gives me 129.81 degrees. So my second angle is 129.81 degrees plus 360k, where k is an integer. So just a quick recap. See, for the first problem, when we solved for x, y, and r, we automatically got the two angles, because when we used the Pythagorean theorem, the x gave me the plus or minus rad 3, which then I was able to break it up into two cases, and I saw my two triangles. But when we were asked to use a calculator, or when we have a problem where we're forced to use a calculator, what happened? We used our calculator, and unfortunately our calculator is only going to force out one of the two angles. So then we need to use our knowledge about trig functions and where they're positive and negative to find the second angle ourselves. But the angle that our calculator gives